Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning in, and special shout out thanks to Marcus for giving me the questions for this video. So firstly, we're going to differentiate fx equals x squared minus 6x using first principles. Hopefully by now you know the derivative of this is 2x minus 6. But when you're asked to use first principles, you need to use this formula here. So in order to use this formula, we need to take this and we need to replace the x's with x plus h's. That's what f of x plus h means. So I take my f of x here, this is x squared minus 6x, that's fx, and I'm going to replace the x's with x plus h's. So I'm going to use brackets to do this, because I want to replace the whole lot. So similarly here, I'm going to rub out x and replace it with x plus h. So in order to substitute this into this part of the formula, I need to expand the expressions. So I'd get x squared plus 2xh plus h squared. That's the first bracket expanded, and the second bracket, when I expand it, I get 6x minus 6h. So I'm now going to substitute this into this formula. So we have the derivative is limit as h approaches 0 of f of x plus h. That's all this. Now I need to subtract f of x. I need to subtract this. I need to subtract the whole shebang here, the whole lot. So I'm going to put brackets around it. So minus f of x in brackets because I'm subtracting the whole thing. And then h goes on the bottom. So now I'm going to cancel out like terms. So x squared minus x squared, they cancel each other out. See, this 6x here becomes a positive because minus 6x is a positive. So I can cancel it out with this. Minus 6x plus 6x gives me 0. After you cancel the like terms, everything on top here should have a h in it. Otherwise, you've done something wrong. If there was a term here without a h in it, we'd be in trouble. So now I'm going to divide. I'm not going to substitute h for 0 because then the denominator 0 causes me all sorts of problems. I'm going to divide. I haven't yet taken the limit, so I still need to write that there. So I go 2xh divided by h gives me 2x. H squared divided by h is just h. And minus 6h divided by h is just minus 6. So now when I take the limit as h approaches 0, I'm going to change all the h's to 0. So this becomes 0, and I'm just left with 2x plus 0 minus 6. And that is the answer that I knew I would get, because the derivative of this is this. All right, let's move on to a parallel perpendicular lines question. So now I'm going to find coordinates on the point of this graph where its tangent is both parallel to this line and then perpendicular to this line. Only the parallel question was on the 2019 exam, but I thought I may as well go through them both. So in order to do this question, we need to know these two facts. Two lines are parallel if and only if m1 equals m2. Remember, m is the gradient. So this is saying two lines are parallel if and only if the gradient of the first line is equal to the gradient of the second line. On the other hand, two lines are perpendicular if and only if their gradients multiply to -1. So firstly, when you're doing a question like this, please make sure you read it thoroughly, and before you start, you're 100% clear on what you're trying to find. So here we're trying to find a point. So we're trying to find a point where the tangent to this curve is firstly parallel to this line here. So what I want to do is find the gradient of this line and then find the point on this curve where its gradient is equal to this gradient. So for 2x plus y equals 4, in order to find the gradient of the line, I need to get y by itself. So if I subtract 2x, I get y equals 4 minus 2x. Now that this line is in the form y equals mx plus b, I can find its gradient. Its gradient is just the number in front of x. That only works when the equation of the line is of the form y equals mx plus b. So the gradient of this line here is minus 2. So this question is asking me to find where on this curve the gradient is equal to minus 2. Now you probably know by now the gradient is the derivative. So I've got to find out where the derivative of this function is equal to minus 2. So we don't really know how to differentiate it when it's in this form. So what I'm actually going to do is expand the brackets. So then we're going to know how to do it. So if I expand the brackets, I get y equals x squared minus 4x plus 5. So that's after I add the 1. So the derivative is y dash equals 2x minus 4. So if I want to find at what point the tangent to this curve is parallel to this line, all I need to do is find where this first derivative is equal to minus 2. So substituting in minus 2 for the gradient, you know how to solve these. I would add 4 to both sides and divide each side by 2. I get x equals 1. So the question asks us for a point. A point needs an x value and a y value. So when x equals 1, in order to find the y value, I substitute into the original. 1 minus 2 squared plus 1, I get y equals 2. So at this point on this curve, its tangent has gradient minus 2, and the tangent is therefore parallel to this line. All right, let's now do if the lines were perpendicular. Well, lucky for me, I don't need to start all over again. If two lines are perpendicular, their gradients multiply to minus 1. I already found out the gradient of the line is minus 2. So, any line perpendicular, its gradient will be minus 1 divided by the gradient of the other line. It will be a half. So the reason the gradient's a half is because minus 2 times a half gives minus 1. So you just do minus 1 over first gradient gives you the gradient of a perpendicular line. So now this question is very similar to what I just did. I'm finding the point where the gradient of the tangent to this curve is equal to a half. The gradient of the tangent is the first derivative. So I actually found out before that the first derivative was equal to 2x minus 4. So now I'm just finding where the gradient is equal to a half. I substitute in y dash for a half, and I solve this exactly the same way. I'm going to add 4 to both sides and then divide by 2. So this time I get x is equal to 2.25. So again, I need to have a point, so I need to sub my x value into here, and that gives me y is equal to 1.0625. So this is the point with my x and y value. So what that means is at this point on this curve, the tangent will be perpendicular to 2x plus y equals 4. So let's just explain quickly and visually what's going on. So in blue is the graph y equals x minus 2 squared plus 1. So this green line here, that's the line 2x plus y equals 4. So if I draw the tangent to the blue curve at this point, it's this line in yellow. And these two lines intersect at right angles at this point here, which is about 2.25, 1.0625. All right, let's now move on to fractional indices. So remember the rule for fractional indices is if you have a to the power of b over c, the bottom number tells you which root to take, the top number tells you which power. We're not spending heaps of time on this on the test, but this does come up in calculus sometimes. For example, if I was asked to differentiate 1 on x root x, I need to write this as a power of x. So this is x to the power of 1 times x to the power of a half. X root x is actually x to the power of 3 on 2, because 1 plus a half is 3 over 2. So whenever we're differentiating, we need to write it as x to the power of something. So this would be x to the power of minus 3 on 2. So when I differentiate it, I'll just call the derivative f dash x. I'm going to do the same thing I've always done. I'm going to move the power to the front and decrease the power by 1. And then I'm left with minus 3 over 2, x to the power of 5 over 2. So just make sure you understand fractional indices. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Best of luck studying.